I thought it was just an. Okay, so we are ready to go, but yeah, can we have? Okay, okay, now we are ready. All right, so welcome everybody. Thank you for being here, and yeah, so today I'm gonna talk about modularization, and I will guide you through a journey from monolith to a multi-module application. And in particular, I will focus on all the stuff that we needed to do in order to start and successfully modularize the tier application. Because spoiler alert, we needed to fix some things before moving on. Just to give you a little bit of context, in the tier application, people can rent scooters, bicycle, and mopeds. And when this application started back in 2018, it was like every initial application, so just a single module with a bunch of people working on. Then, of course, the project gained traction. There was more user, more features to be added, and also we needed more developers to join in order to build that features. So the single module became a very big module with all the code in the same place, and we had some issues. So, for example, there wasn't a clear ownership of the code that each team owns. Then, of course, having all the code in the same place increased also the possibility of merge conflicts, and also the build time decreased because, yeah, if you have just a big thing and not multiple things, the Gradle will slow down. So, in order to fix all those issues, we decided to move to a multi-module structure. Because with multiple modules, you're gonna also simplify the development, because you need to be careful on how you plan your architecture, because you need to separate your code. You need to have cleaner interfaces in order to let other user use the code. And with that, you're gonna also earn a clear ownership, because a specific team can own a specific module. So you're gonna know for sure what people is work on and what people own. And as a side effect, also you're gonna have an improved build times, because sometimes Gradle can be smart and it can parallelize the builds. So you avoid having a serialized build time for every module, but it can parallelize stuff and build in parallel. So the build time is improving. Before moving on, of course, disclaimer, because especially with modularization, there's not a right way of doing things. Every application and every project has its own problem, its own issues, so its own peculiarities. So there's no a perfect recipe in this topic, but you need to figure out what's work perfectly for your project. So the general concept that I'm gonna show you today could be, and I hope that it will be perfect also for your project, but maybe some details could not work. But of course, the general idea will be applicable. And also, it's the first rule of development that it depends. Okay, so now that we have all the disclaimer in place, the first thing to do is deciding the architecture that you want to have. And as I said before, there isn't a perfect plot for every project, but there is a standardized kind of way. Because every modularized project usually have three different layers of modules. The first one on the top is the application, where there's the application module, where you initialize stuff and you do those kind of things. Then there's usually a features layer, where you have module that contains features. So, for example, your home screen, your settings screen, and stuff like that. And at the end, there are layers of libraries where there's reusable piece of code that can be described as a library. So, for example, logging, networking, analytics, stuff like that. So this is the general kind of concept. And specifically for our application, we ended up with a structure like that. So with mostly the similar. And yeah, let's dive deep into that. So starting from the bottom, we have a special module that we call shell that contains all the shared common code. So in there's code like DTO, some common DTOs, some models, some utilities, for example, schedule provider, stuff like that, that will be used in multiple places inside your application. And of course, this should not be yet another monolith just with a different name. So you need to be careful on what stuff you put into that. And most important thing is that this module doesn't depend on the upper layers. So basically, it's just kind of an independent module without any reference to the upper level of our layer structure. And so basically, it has only dependency on external dependency and stuff like that, not anything inside the project. And that was the bottom layer. So another thing, as a rule of thumb, we can think that every layer in our graph depends only on the bottom, on the stuff that they see on the bottom. This is the rule of thumb that always works. So let's move up, and this time we are reaching the libraries level. And on the libraries level, there are, guess what, libraries, which are, as I said before, are just small reusable components, like utilities, analytics, and stuff like that. And libraries module can depend only on other libraries, or can depend only on the shell. They doesn't depend on stuff that are above them. Okay, by moving up, in the features layer, we have, guess what, features. So inside that, there could be features that have that are user-facing features or not. And by that, I mean, for example, the entire onboarding flow, the home screen, and stuff like that. Or can be also a feature that doesn't have user interface at all. So, for example, the code to retrieve the location of a user. And for every feature is composed by two modules. There's implementation modules, and there's a contract module. The contract module contains, of course, the contract of that feature. So basically, what a feature can do and how the feature can be launched. So in reality, by looking at some code, this will contain just interfaces and data classes for the model required by the interfaces. And the contract can depends only on libraries and can depend only on the shell. So again, only on the stuff that they see at the bottom. The implementation instead, it contains the implementation of the contract. So it needs a dependency on the contract, and this kind of module can depend also on other feature contract, because, for example, you want to launch a specific feature from another feature, but again, for the rule of thumb, can only depend on other libraries and on the shell. And those kind of modules are somehow special because they are basically invisible to the entire application except for the app, because it's only because that's how the thing is implemented. And let's see why. So as I was saying before, you must sometimes launch a feature from another feature. But you cannot, in this architecture, start that feature directly from an implementation module. But you have to go through the contract. Why is that? Well, first of all, because it allows to have low coupling. So you can avoid to have knowledge of the inner workings. So for example, you want to just launch a feature from that another team has developed. You don't care about the internals. You don't care on how it's done. You just care about starting something. So in this way, you can avoid looking into the source code to understand how the thing is done, because you just have to read an interface and that's it, basically. The second point of doing that is the fact that you can, if you're not using a contract, you risk to need to import a lot of transitive dependency if the feature that you are importing is using a lot of transitive dependency. So if the feature that you want to import depends on other feature module, you need to import that as well. So by using a contract, you can avoid that. But the most important thing is that you can avoid to increment the build time, because if your feature module, you import another module, and then there's a modification in that module, if then after the modification, you need to rebuild everything. But instead, if you just depend on the contract, then if the implementation of that contract changes, you don't need to rebuild the whole chain, but just the implementation itself. So this let you save some precious build time. Okay, so that was the core of the layer. Now we reach the top layer, that is the application module. And the application module basically is responsible only for initializing the application. It set it up, of course, also the dependency injection graph. And it is responsible to link all the modules together, because the application is the only module that sees everything. And of course, we should keep the app module as slim as possible, because we are moving away from having everything in the app module. So we need to keep it slim, because it's a module that is just responsible for launching the application and not for doing everything else. Okay, so we cover the entire architecture graph, but this is an ideal situation, because in this architecture graph, there's no the current code that it's non-modularized, and the real one graph is this one with a big legacy red on fire module that contains all the non-modularized code. So we basically decide to move all the non-modularized code of the code base inside a specific module and not let him inside the application. So we have everything that is legacy in one specific place. So we can start then after that extracting feature from this place. Of course, we should try to not put any new code in it, because it's a legacy module, but I said should, because we never did that, because it's way more easier to just put in there, because you have all the dependencies, stuff like that, and at the beginning of the modularization especially is kind of difficult if you are at the beginning. So for the time being, we just put stuff in the legacy again. Okay, and this legacy module is just is like a feature module. So basically, it just have a different naming because it's a legacy one, and since it's a feature module, it can depend on other contract, it can depend on libraries, and it can depend on shell. All right, so we have a really fancy architecture, really explained, stuff like that, but how we can try to stick with that? Well, first of all, we are all humans, luckily, so we can talk to each other, and write some documentation about that, align between each other. But since we are all human, we must need some machinery to prevent doing mistake. So we also added a simple Gradle plugin that checks the dependency graph if we are doing something bad. So for example, using a feature module inside a library, then the Gradle plugin will fill the build and shut it out, the thing. Okay, so after doing whiteboard, basically, it's now time to finally write some code. So we can start doing stuff. And in order to do stuff, you need to start from somewhere. So you can select a feature to start with. And it can be a feature that has UI inside or a feature that doesn't have UI inside. And I can assure you that starting from a feature that doesn't have UI inside it, it's way more simpler because, spoiler alert, with UI features, you need to handle navigation. And yeah, handling navigation, it's hard on. So we're gonna jump on that later on. So in our specific case, we decided to start extracting our feature from the code that handles a scooter ride, because we just at that period we just refactored that, so it was new shiny refactor code, so it was kind of perfect to start with those things. The first thing that you need to do before starting, when you need to start extracting stuff, you need to find which dependency you are using that are shared between other modules. So in this case, from that are shared from the application, because at that period we haven't created yet the legacy module. So in order to find that, you can go the hard way, so just move it and then find where the builds fail. But you can also use a handy feature of Android Studio, which lets you select a folder, a module, or even the entire project, and it basically prints you out all the dependency that your specific file are using. So you can check that and decide which of those shared dependency you need to move to the shell in order to make all the stuff work. So we move them temporarily to the shell because, yeah, it was the most convenient way of doing things back then. But of course, later on you need to extract them from the shell, because otherwise the shell becomes just the new monolith, and we don't want that. So after doing that, we extracted the ride handling feature into a new module, and we were successful. The trial went well. And we ended up with a new shiny feature module, a new shiny shell module, and still a big application module. So it was time for create the big red legacy module. So we moved the remaining code into this new module. And of course, in that process, we kept moving some dependency to the shell because, yeah, there was some other dependencies shared altogether. So from this structure, we slimmed out the application module and ended up with a new feature module that is the legacy one with, of course, the big red shining thing. All right. After starting with the easy stuff, it's time for more hard stuff. So it's time for a UI feature. And the main question when you start dealing with UI feature modules is how to navigate between different modules. And here we hit our first big blocker. So, yeah, we need to kind of rethink everything, because the way we were doing navigation, it was not enough for a multi-module project, because we were using JetPack navigation. And the way we're using JetPack navigation is that every feature has its own navigation graph. So for example, for the onboarding, there is a graph. For the shop, there's a graph. For the settings, there's a graph, and stuff like that. So we didn't have a single activity architecture, but rather each feature has its own hosting activity. So let's visualize that a bit. So for example, in the application, there's a shop. So there is a shop activity that hosts the shop feature. It has its own navigation graph. And inside of that activity, there are multiple fragments. So, for example, there's a fragment that shows the list of articles that people can buy. There's a fragment that shows the details of that article, and there's a fragment that show a successful purchase. Of course, only successful because we don't allow failure on that shop, and yeah, only successful. And yeah, this is the structure that we have right now, but we want to keep that stuff. So when we gonna have a new feature module for the shop, we want to keep that shop activity and with all this stuff. So what we want at the end is the capability of just starting a feature from another module. So for example, inside the map activity, we just want to start the shop activity. And another use case that we have is just that we still want to start something from outside, yeah, but we want also a result back from that. So the classic example is the QR scanner activity that has different flows, but we want a result back to be handled. And also another use case that we have is a bit more complex. So for example, we want to simply add a fragment in the current navigation flow. So for example, in the shop activity, like I said, we have a flow of different fragments. And so at a certain point, we want to just call the customer support fragment because the policy of only successful purchases fail. And but we don't want to start an activity for that because we want a complete flow of a natural flow of different screen. So for this case, we just want to add a fragment from another module simply in the current flow. So in order to do all that stuff, there are some issues because starting a feature from another module can be easily done with the setup that we had of Jetpack navigation. If you have a deep link and a single activity that contains all the different graphs. And so in our specific case was not so much possible. Then for starting a feature and getting a result back, it's not kind of possible on Jetpack navigation, so you have to start doing all the old but gold way. And then adding a fragment in the current navigation graph, good luck of doing that with Jetpack navigation. So we had to fix those kind of things. So for the first thing, so just starting a feature, it's quite handy because we can use the contract that we introduced before, because we can have in the contract module just an interface that launches the feature. And then in the implementation module, you can just have the glue code that is necessary to start your activity, since the feature has a activity that contains the whole feature. So this was pretty handy. For the second case, so getting a result back, this is kind of the same, because you can again use the contract, have an interface with a simple function that accepts also a callback, and then you can just use the new API from start activity for result and call the callback when you're done. And finally, for the latest step, so adding a fragment in the existing flow, we can again use the contract, because we can have a function that just simply returns the fragment that we want, a new instance of the fragment that we want, and yeah. But the problem is that you return an instance of that fragment, but the fragment could behave differently in its own feature, or in the feature where we are importing that kind of thing. So for example, when you click back, you probably go into another screen in the specific feature. So we needed a way to handle different navigation in different scenarios. So in order to do that, we introduced a new pattern, for us, because a router is not something complex and something new. So basically, what we thought is that if a feature want to expose a specific subcomponents, so in our case, if we want to expose a contact support fragment, we must also expose our router for that subcomponents. And a router will be simply an interface with some function that are doing stuff. So in this case, for example, navigating back or starting the flow for calling the customer support. And then every feature module has an internal router where it handles navigation inside it. And if it wants to also import a subcomponents, it needs to import and implement the subcomponents router. So let's check some code to make it more clear. So, for example, we have a specific feature that is navigating to the map. So in this case, we have it's the router for that specific feature, and it has a specific function to go to the map. But then it also wants to navigate to the customer support stuff, and so it needs to implement the router for the customer support. And in order to do that, it must override the specific function exposed by the router of the feature. So in this case, it's overriding it, and it's just sending navigation events to something. And those navigation events can be then observed from the external world. So, for example, from the view model, so we can handle navigation. The navigation event in our case are exposed with an observable, because we are still using Rx, but could be a flow or whatever you want. And this observable basically hides Rx relay, but a customized version of a relay, because we wanted a similar behavior of a single live event that you probably have used if you're using live data. So basically, we wanted a relay that emits the data if there's no subscriber, but a subscriber arrives later on. But we want to not emit all the stuff to existing subscriber, because we don't want to randomly trigger navigation or could be fun for the user, but not so beautiful. So a new navigation approach. To sum it up, we have every module that manages internally the navigation with the router, and if he wants to import something, a submodule from the external world, it needs also to implement the router of that external subcomponents. There could be different subcomponents routers, so the correct one is retrieved using scopes of the dependency injection library that we are using. And then the navigation is handled manually, the good old way, with start activity, fragment support manager, stuff like that, and not with Jetpack navigation, because it was not quite handy with multi-module structure for us. But the most important thing is that with this approach, changes can be gradually introduced, and not with a big bang approach that stop us for a month to migrate to the new process. And finally, also an important thing is that in this way we can also unit test all the navigation behavior, which is a good thing to have in place. That was enough for navigation. Another thing that we needed to do was improving Gradle setup, because we still had some version number of libraries that was hard-coded around. And that's not a good thing to do with if you have multiple modules, because good luck on updating a library and find all the different versions that in the different modules. So we decided to take the chance to migrate to Gradle version catalog for managing dependencies, which is a new way introduced by Gradle of doing things. So you need to declare your dependency in a TOM file. So it's pretty good, because you have a single place of thing where you have your dependency. And also it has an amazing feature like bundles, where you can put all the same and similar dependency inside it and just import that thing. And for compose is just amazing to just have to import one thing and not 1,000 of different libraries. All right, another thing for having a better Gradle setup for multi-module project is having a single definition for min SDK, compile SDK, stuff like that. So again, if you need to update, you don't have to go all around the places. And in our specific case, for historical reason, we had the build source folder set it up, so we put that in place. So we have a function that we can call on every module in order to set it up automatically, the stuff that we want. It's working, but the long run would be to move to Gradle commercial plugins, because it's more beautiful than having the build source folder. So this will be the future. All right. Of course, since I'm always lazy, I don't want to create manually every time a contract, an implementation, have copy and paste the Gradle dependency, stuff like that, because it's a boring work. So we use a cookie cutter template that is a kind of Python, if I remember correctly, library to automate stuff. So we made a CLI tool that lets us quickly create a feature module or a library module with all the boilerplate required. So you just have to write some stuff, and it even updates our code owner file. So it's quite tiny. My secret dream is build Android Studio plugin with Compose, but a CLI for the time being it's just enough, and it does its job. Okay, so that was enough to restart doing things. So basically now we can finally, with the navigation place, the new navigation place, we can just resume building a UI feature. So we started with a small feature, because we needed to validate navigation, so we don't want to import a big thing. And it was successful, but after that, another beautiful block, because we quickly realized that we needed more utilities modules for more complex UI feature. And of course, we don't want to move that stuff in the shell and became the new monolith. So we stopped it again for some other dependency analysis, and we just created new modules. For example, for feature flagging, for testing tools, for analytics and stuff like that. And after doing that, we successfully resumed UI modularization with almost all the utilities ready for that. And we kept going on that. Okay, it was quite a long journey and with a bit of roadblocks, but we managed. And so let's try to sum it up with some conclusion. So when we started back in July 2021, so basically more than a year ago, with the first architecture analysis, so with the whiteboard and stuff like that. And we ended up in May of this year with finally a big UI feature module successfully modularized. So it took almost a year to have everything in place, which seems a very long time, but I can assure that it's not, because yeah, you need to figure out a lot of things in order to have a satisfying modularized place. So specifically for us, the structural work was that after 6 weeks of doing what PMs tell us, basically, it was so after 6 weeks of feature delivery, standard feature delivery, we had 2 weeks of cooldown. So basically, we can just eliminate PM from our from our work, and just all developer have big chunk of planning or work. And in those periods, we had the most stuff rolled out. But of course, the works didn't stop at that 2 weeks. Otherwise, it would be impossible. But some of us continued with work happen also underneath during the 6 weeks period, without telling the PM, of course. No, I'm joking. Okay, so as I said, it was it's a long and difficult journey, but it's totally worth it, because you're gonna end up with a much cleaner code base with. Because modularizing, creating a module forces you to think about boundaries and dependencies, stuff like that. So at the end, it will be a better code base for sure. The bad news is that there's no the perfect recipe for doing that, because yeah, modularization, it's a huge topic, and different projects have different needs, and there's different requirements and stuff like that. So yeah, you need to find the perfect balance for your project. And also because of that, don't be afraid to fail in the process, because yeah, since there's no perfect recipe, you need to find the way for the correct path for you. So just try things out, and yeah, once you find the perfect road for you. Another thing is, don't rush the process, because you don't need to finish everything as fast as possible, because yeah, otherwise you're gonna stuck on, yeah, I have to do, let's go. But think about it and prioritize the blocking works first. So for example, for us was fixing navigation and then other stuff. But once you fix your important roadblocks, then everything could be go with the flow. Another thing that is very tempting, because you're checking old code, don't refactor the code that you see during this process, because yeah, it's tempting, because you see, oh, what's that? And but if you stop for refactoring it, then you never finish the modularization. So just put a to-do, ticket, a post-it, whatever you are using, but just leave it there, close your module, and then commit back later, or never commit back, like most of the time. And also a final pick is that with modularization, you have the chance of find, let's call it hidden pearls of your project. You can find interesting and kind of funny things in your project. The feature developed 2 years ago for people that left, that you don't know what the heck is going on in there. So yeah, it will be an experience full of learnings. Let's put it away. All right, so those are some resources that could be useful for your process. I'm gonna post it on Twitter, so don't worry if you don't manage to catch a picture. And that basically was it from my side today. Thank you very much for the attention. If you have any kind of question, if we have time, you can shoot it out now. Otherwise, find me around and just ask me.